Assalamu alaikum students, hope you're doing good. Kindly mark your attendance in a chat box. So students, mark your attendance in a chat box. Uh, so students, we are going to start Unit 5, and today we will revise the Unit 5 topic artificial satellites, right? So first of all, we see what are the satellites. Satellites are basically the objects that revolve around the Earth. So there is only a one natural satellite, and all of you know that that is a moon. So moon is a natural satellite because it revolves around the Earth. Then we see that what are the artificial satellites? Artificial satellites are basically the objects that revolve around the Earth. And scientists have sent many objects into the space for different purposes that are revolving around the Earth, and they are known as artificial satellites. So the basic purpose of artificial satellite is that they are using for the communication purpose, that we are seeing the different news on our TV, and we are getting different information just because of these artificial satellites. So if you see figure 5.6, this is our Earth, and the radius of Earth, we all of know that represented by the capital R. So from the center to the end of the Earth, this is the R, and this R is basically the radius of Earth. And if suppose there at some height, if there is supposed any satellite is placed, then the distance of this satellite is measured with h, that is known as altitude, right? So at it placed on some height, so we represent it with small h. And you know that this is the radius of center of the Earth, and this center of the Earth to this end point where the artificial satellite is placed, this is basically the radius, which is known as small r. Normally, if you see that this is a circle, right? So if you divide this circle in an equal part, it will be equals to diameter. And if you further divide it, this part is known as radius. So this is the same case like here. So this h and this r give us the value of this radius. So h plus r is equals to radius. So h is basically the altitude, which is the height of satellite from the Earth, and capital R is the radius of Earth, which is equals to the small r. And small r is basically the total radius, which is basically known as the orbital radius, where the satellite is placed, right? So now we will see that how many satellites they are revolving around the Earth. So there are large number of artificial satellites have been launched in different orbits around the Earth. They have taken different time to complete their one revolution around the Earth, depending upon their distance h from the Earth. So students, the distance h is very important if for the satellites that are revolving around the Earth. If the distance is very close to the Earth, that satellites there appeared as a stationary satellite with respect to the Earth. But if there's a larger distance, these satellites, they are not appear to be stationary, and secondly, they are taking more time to complete their rotation, right? But if a satellite is very close to the Earth, um, the distance is less, so they will complete the revolution in a less time, just say the revolution of Earth, right? In 20, as our Earth complete a rotation in 24 hours. Similarly, the Earth is near to the Earth, close to the satellite is very close to the Earth, so it's also complete its rotation in 24 hours. And these satellites, that are very close to the Earth, they are basically appear stationary with respect to the Earth, and their orbit is known as orbital geostationary orbit, and the satellites, they are known as geostationary satellite. So if we read this, you can also open your book, the topic artificial satellite. It is due to the reason the orbit of such a satellite is called geostationary orbit. Dish antennas sending and receiving the signals from them have fixed direction depending upon their location uh, on the Earth. So now we will see the motion of artificial satellite, and how these satellites, they are move around the Earth. So whenever the word motion come in your mind in physics, it is basically the velocity, right? So it's mean we have to find out the velocity of the artificial satellite. So as a satellite is revolving around the Earth, the motion of satellite is in a circular path. So if you just recap unit 3 topic, centripetal force. So centripetal is basically a force that keep the object to move in a circular path. So obviously this satellite also has a centripetal force that keep it moving around the Earth in a circular path. Second, if you see the law of gravitation that we have learned in the start of unit 5, the law of gravitation is basically the attraction between two masses, and that is directly proportional to the force of attraction, and inversely proportional to the square of distance between them. So as there are two objects, the one object is satellite and the other object is Earth, so there is also a force of gravitation between these two objects. So they are the two reasons that satellite is revolving around the Earth. One is a gravitational force, and second is a centripetal force. So these two forces, they are very important for the motion of artificial satellite around the Earth, or you can say that also for a natural satellite. So for to find out the motion, first we have to take the mass m of a satellite that is revolving around the Earth, and obviously it is moving with some height h. So we can say that the altitude is h, and the orbital radius of this satellite is r naught. So r naught is equals to r plus small h, right? That we have discussed in the previous slide. And the and as this object satellite is moving, so obviously it is moving with some velocity. So for artificial satellite, we can say that it has the orbital velocity, and orbital velocity is represented by v naught. This is v naught, right? So the first thing is that we know the mass of satellite that we have represented by small m. The height, altitude is, it is placed at distance of h, and the radius of this satellite is r naught, and the orbital velocity is v naught. So as we have discussed earlier, that this artificial satellite has moving with respect to some centripetal force, right? So we know that the formula for centripetal force is Fc is equals to mv square by r naught. But here the velocity is v naught, so we write v naught instead of v, and r naught is the orbital radius. So this is the centripetal force that keeps the satellites to move around the Earth, right? Then second force is given by the force of gravitation, that is between the satellite and the Earth. And here the gravitational force is equal to the weight, because there is a height and this satellite is directed towards the Earth downward, right, to the center of Earth. So here the gravitational force is equals to the weight, and all of us know that the weight is equals to W is equals to mg. So here the W is equals to mgh. Why gh? Because if you see, this is the Earth, right? This is the Earth. The gravity on the Earth is G. To the center and to the edges of the earth, the gravity is G. But as we are moving on the altitude, some height, the value of G is start decreasing. So for the height, we represent the value of G with, we write G, and in subscript we write small h, which represent that this is the gravity at height. And it also showed that this gravity is lower as compared to the center of the earth, right? So this W is equals to mgh. So this is also a force and this is also a force. So what we have to do, we have to compare all these two forces. When we compare these forces, what will happen? They will be equal to each other. So we can write these forces as mgh is equals to m naught mv naught square by r naught. So these are the two forces, they will be equals to each other. One is a gravitational force and the other one is a centripetal force. So when they equal with each other, what will happen? The same quantities, they will be cancelled out with each other. So if you see in this figure, which quantity is similar, the mass is same on the both side. So what we have to do, we have cancelled this m with this m, and we left with gh is equals to v naught square by r naught, right? So when we cancel out them, we will get the equation that is v naught square is equals to gh r naught. So as we are going to find out the motion of artificial satellite, so we have to take the square root on both sides. So it will is equals to v naught is equals to gh by r naught under root, right? So in the start we have discussed that this radius, orbital radius, is equals to the radius of earth, that is from the center of earth, plus the altitude at which the satellite is placed. So we just put the value of this r naught over here and we will get the equation. V naught is equals to gh into r plus h, right? So this is equation 5.10 gives the velocity which satellite must possess when launched in an orbit radius r naught plus r plus h around the earth. So if we consider that this satellite is revolving around the earth and this satellite is very close to the earth, when this satellite is very close to the earth, what will happen? This r is much is equal to this h, right? Because it is very close to the earth, then there will be no altitude, means there is no h. So we just consider this as r plus h is equals to r. And obviously when it will be very close to the earth, then the gravity will also become g, because on the earth the gravity is g, that is equals to 10 meter per second square, and it is very much as compared at the height, right? So by putting these two values in the equation 5.11, we will get V naught is equals to under root GR, right? This is equation 5.12, and this is basically the motion of artificial satellites. So if you anyone asks from you what is the mathematical form of motion of artificial satellite, you can say that V naught is equals to under root GH for the case when the satellite is revolving very close to the earth. But if the satellite is present on some height, so the formula will be V naught is equals to under root GHR plus H, right? So if we just put the value of G, the value of G is 10 meter per second, or you can write take as 9.8 meter per second square, and the radius of Earth is 6.4 into 10 raised to power 6 meter, and it is a constant value, it cannot be changed. You just put the value in this equation, you will get the answer. V naught is equals to 8 kilometer per second, or in kilometer per hour it is 90,000 kilometer per hour. So the satellite that is revolving very close to the earth has a speed of 8 kilometer per hour. So these are the points that have to be remembered. So in this way we can calculate the motion of artificial satellite. Now Come to the exercise questions. I know that all of most of the students, they have already done these questions, but for some students, they don't have completed their work. You can complete their work now, okay, with the help of these question and answers.
Ma'am, can you also show me 5.1 so I can take the screenshot?
Beta, I will upload this lecture on Google Classroom. You can take screenshot from there, okay?
Okay.
The first question is 5.2, that is, what is meant by a force of gravitation? You just write the definition. There exists a force due to which every body in the universe attracts everybody. Then second question is, do you attract the earth or earth attracts you? Which one is attracting with a larger force, you or earth? So in this case, you see that the earth and you are the two objects. So according to the law of gravitations, both are attracting to the each other with the same force, but in opposite direction. And also the Newton's third law of motion is also valid over here. So gravitational force between earth and person is a mutual force. According to the Newton's third law of motion, action and reactions are equal in magnitude but opposite in direction. So both an earth and person attract with the same force but in opposite direction. This is the answer of question 5.3. Then 5.3 is, what is a field force? You just have to give the definition of a field force. That is the gravitational pull of earth acting on a body, whether the body is in contact with the earth or not, is a field force, right? Then we have 5.4, why earlier scientists could not guess about the gravitational force. So the reason is that the earlier scientists, they could not guess about the gravitational force because the value of g is very small. If you see the value, if you see the value of g, the capital value of g is 6.673 into 10 raised to the power minus 11. So you know that the 10 raised to the power minus 11 is a very small value. Even we cannot feel in our daily life because this value is so small. And at that time, this sensitive instrument is not invented, so that's why the earlier scientists could not guess about the gravitational force. And the instrument that is used to measure the gravitational force is a gravimeter. So you can just write the answer. Earlier scientists could not guess the force of gravitation between two masses because it has a very small value. It could not be detected only by a very sensitive instrument which were not invented at that time. This is the answer of question 5.4. Then 5.5 is, how can you say that the gravitational force is a field force? The gravitational force is a field force that exists in a space around every mass or a group of masses. This field extends out in all the direction, but the magnitude of the gravitational force decreases as the distance from the object increases. So this is the answer of 5.5. Those students who have already done in answer these questions in their notebook, they don't need to repeat them. But those who haven't done, they have to do in their notebook. Then the next question is 5.6. 5.6 is, how can you say that a gravitational force is a field force? The weight of a body is due to a gravitational force with which the earth attracts a body. Gravitational force is a non-contact force for which the velocity of a body is thrown up goes on decreasing, while on return its velocity goes on increasing. We also have experience in our daily life. If you throw some objects in the upward direction, at the end it will become in a downward direction because of the gravitational pull that is acting on the body, whether the body is in contact with the earth or not. Such a force is called a field force. So we can assume that a gravitational field that they are existing all around the earth, this field is directed toward the center of earth. If you see the figure 5.3, it is shown over here. These are the gravitational field that are shown by a arrowhead towards the center of the earth. So as their direction is inward, so all the objects that are thrown, they are attracted towards the earth. So we can say that gravitational force is a field force. So this is the answer of question 5.6, and you have to draw the diagram of uh, you have to draw this diagram with this question as well. Now the next question is 5.7. For 5.7, they are asking that explain what is meant by gravitational field strength. So first of all, you have to tell that what is a gravitational field strength. Gravitational field strength is a gravitational force that is force per unit mass, right? Then you have to tell that what is the value of gravitational field strength. At any place, its value is equal to the value of g at that point. So all of you need to know that the value of g is 10 meter per second square, and in case of gravitational field strength, it will be become 10 Newton per kg, right? So you have, this is the answer of 5.7. Then there's a 5.8, why the law of gravitation is important. So we have to see the importance in our daily life. So according to the scientists, the law of gravitation, it is important to us because it is responsible for the motion of moon around the earth. The motion is revolving around the earth because of the gravitational force of attraction between the two objects, and the two objects are, one is moon and other one is earth. Motion of planet around the sun, and it is important to releasing satellites from the earth. This is earth. This is correct the spelling, this is the earth, right? EARTH, this is the earth in the orbit. The fourth one is the law of gravitation describes a phenomena like gravitational force between a planet and a star, rotation on and revolution of heavenly bodies and galaxies. So this is the answer of question 5.8. Now the next question is 5.9, that is explain the law of gravitation. So in this case, you have to explain the law of gravitation. So what is the law of gravitation? You have already learned in the regular classes. First of all, you have to give the statement of a law, that is everybody in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square distance between them. Then you have to draw this diagram that is already discussed, and you have to write consider two bodies that are have masses m1 and m2, and the distance between the center of their masses is given by d squared. So you have to write all these along with its diagram. Then you have to explain this law with the help of these statements and mathematical equations. According to the law of gravitation, the gravitational force of attraction F with which two masses m1, m2 separated by distance d attract each other is given by F is proportional to m1, m2. F is inversely proportional to d square. If you combine above two equations, you will get F is proportional to m1, m2 by d square. Yes, Adeem.
Ma'am, can you show me the previous slide once again?
Okay, wait. Yes, Sadeem, this is a previous slide. In this question, they are asking that you have to explain the law of gravitation. So what you have to do, you have just state the law. Then you have to explain this law with the help of this figure 5.11, and you have to write the theory and just drive this relation, right? So by adding these equations, you will get F is proportional to m1, m2 by d squared. So this is F is equals to G m1 m2 by t square. So this G is the value that is equals to, G is equals to proportionally constant. It is called the universal constant of gravitation, and its value is seen everywhere in SI unit. Its value is 6.673 into 10 power. You don't have to write this one, this is by mistake. 10 power minus 11 Newton meter square per kg square. So you have to give the answer of this question till here, right? Then the next question is question number 5.10. How the mass of Earth can be determined? For that, you have to draw the diagram, you have to give the explanation and derive the relation for mass of Earth, then put the values in the equation that you have find out to get the value of mass of earth. For that you have to give the heading of mass of earth, then you have to draw this diagram 5.4. This is the earth, this is the mass of earth, this is the radius of earth that is represented by capital R. Some mass is placed on the earth that is represented by small m, and it's directed toward the center of earth with the force equals to weight, right? So first of all, you have to draw this diagram. Then you have to give the explanation that of this diagram, that consider a body of mass m on the surface of Earth as shown in figure. Let the mass of Earth be me, all of you know that, and the radius of Earth be a capital R. The distance of the body from the center of the Earth will be also equal to the radius of the R of the Earth, right? So according to the law of gravitation, by if you are using the law of gravitation, then this equation will be become F is equals to G m small m capital me by R square. This is one object that is replaced by m1, and this is second object that is replaced by m1, and here the distance is r square, so we replaced it by d square is replaced by r square, right? So you have to write this equation. Then the second force is a force that is acting downward, which is equals to weight, that is W is equals to mg. So these two, when you compare these two forces, it will be equals to mg is equals to capital G m me by r square. If you see equation 5.5, you can see that the m is cancelled out with this m, right? The equation left behind is G is equals to capital G m e by r square. As we have to find out the relation for mass of earth, so what we have to do, we have to separate this me. For that we have to take all these quantities on the other side to find out the value of me. So me is equals to r square G by capital divided by capital G. So this is a relation that is derived for mass of earth. Now, to find out the value of mass of Earth, what we have to do, we have to put the values of radius of Earth, that is always constant, and we know that its value is 6.4 into 10 raised to power 6. Then we have to put the value of G, that is equals to 10 meter per second square, and this capital G is equals to 6.673 into 10 raised to power minus 11. So by putting all these values in this equation, when we calculate this, we get the equation, we get the value 6 into 10 raised to power 24 kg. So the mass of Earth is 6 into 10 raised to power 24 kg. You have to write 24 over here, right? So this is the mass of Earth that we have to find out. So this question, we just have to draw the diagram, give the explanation of the diagram, then drive the relation for mass of Earth by putting the value. We get the value of mass of Earth that we have to write over here, right? So I think this is enough for today. You have to just complete these questions in the notebook if you haven't done, for those students who haven't completed. But for those who have already done, you don't need to repeat these questions, right? So if you have any question in this lecture, you can ask me, otherwise we can end the meeting. Okay, so if you have any question, you can ask me. No, Iman, you don't have to change the answer for 5.5. You can both answers have the same meaning. So if you done the 5.5 that we have in the class, it's the same like this. So there is no need to change, right? Any other questions? If you have any question, kindly let me know. Otherwise, I have to end the meeting. Okay, girls and students, Allah Hafiz. If there is no questions, we will end the meeting. Thank you.